Hello everyone. Our today's topic is we are going to start new chapter. The chapter is equilibrium. If we define equilibrium before this, we should know there are two types of the chemical reaction. First one type is called as a reversible reaction and second type is called as a irreversible reactions. Reversible reactions are those reactions which can move in both forward and backward direction, while irreversible reactions are those reactions which only proceed in one direction, in the forward direction. And reversible reactions are represented by double-headed arrows, while irreversible reactions are represented by single arrows starting from reactant and pointing towards the product. Now, for the establishment of equilibrium, a closed system is required. A closed system is required. For example, this diagram clearly indicates this situation. If we have a container in which we take calcium carbonate and heat it. If the container is open, definitely on heating, calcium carbonate will be decomposed into calcium oxide and carbon dioxide, and that carbon dioxide will be escaped out quite easily into the atmosphere. That's why the decomposition of the calcium carbonate will continues in the forward direction, and more calcium oxide and carbon dioxide will be formed, and that will be good. But if we take calcium carbonate in a closed system, then what will happen? If we heat, now calcium oxide and carbon dioxide will form. Calcium oxide is also solid, calcium carbonate is also solid, and carbon dioxide is gas. For example, here are the gas molecules. Whenever this whole of the space above the calcium carbonate will be occupied and carbon dioxide has no chance to escape out, what will happen? Now, in turn, carbon dioxide will start striking again with the calcium oxide. As calcium oxide is basic in nature, carbon dioxide is acidic in nature, then both of these will react together and again calcium carbonate will start forming. In this manner, it means that in a closed system, there is a chance of the reaction to go back in the backward direction automatically. In a closed system, it means that both forward and reverse reaction will take place, and in this case, whenever the rate of reaction in the forward direction becomes equal to the rate of reaction in the backward direction, then that situation is called as equilibrium. Now, sometimes this is also named as a dynamic equilibrium. Why dynamic? Dynamic means it is always in a continuous motion. Reactants are changing into the products and products are changing into the reactants continuously. If this cyclic process or continuous process carry on, then whenever the rate of forward reaction becomes equal to the rate of backward reaction, that situation is called as a equilibrium, and equilibrium is established. Now, this can also be represented by graph. For example, in the start, reactant has maximum concentration and product has zero concentration. Whenever reaction starts, product concentration increases and reactant concentration decreases. If both reactants and products are interconverting with one another and the reaction is proceeding in both forward and backward direction, then automatically a point will reach where the concentration of the reactants will become constant, same, and if at that point reactants are changing into products and products are changing into the reactants, then at that stage we will call this equilibrium or dynamic equilibrium. Now, It means that there are four main points for the establishment of dynamic equilibrium. Those 4 points are: number one, the equilibrium must have a closed system. Second, the rate of forward reaction should be equal to the rate of reverse reaction. And third, at equilibrium, the concentration of the reactants and products become constant, same. Now, if we want to discuss the different factors which can affect the equilibrium or dynamic equilibrium, then a famous rule we have to use, that is called a Le-Chatelier principle. Le-Chatelier principle defines that if a process in equilibrium is disturbed by some change, then the process or reaction will behave in such a manner to restore the same equilibrium position and to undo the effect of that change. This is called as a Le-Chatelier principle. If the reaction is in equilibrium already, then definitely if we make some change in that, the reaction behave in such a manner to undo the effect of that change. This is called as a Le-Chatelier principle. Using Le-Chatelier principle, we can discuss the effect of different factors. For example, we can discuss number one, effect of concentration on dynamic equilibrium, effect of temperature on dynamic equilibrium, then effect of pressure on dynamic equilibrium, and finally we can discuss the effect of catalyst on dynamic equilibrium. Now, if we take the example of ammonia formation, for example, we know that 3 moles of hydrogen reacts with 1 mole of nitrogen and change into ammonia gas. Now, initially the reactants change into product, but after some time these products once again start changing into reactant in the backward direction, and whenever the rate of forward reaction becomes equal to the rate of reverse reaction, that situation will be called as an equilibrium. Now, whenever we create some change, it means that the reaction present in equilibrium is not in equilibrium whenever we will draw some change. For example, effect of concentration. If I will increase nitrogen or hydrogen reactants, automatically the position of equilibrium will shift towards forward. Increasing the concentration of reactants, reaction will move forward and more products will be formed. Inversely, if we increase the concentration of ammonia, then the reaction will move in backward direction to attain the same equilibrium position. That's why the position of equilibrium will shift towards left side. And similarly, we can also judge the effect of decrease in concentration. For example, if we decrease the concentration of reactants, then automatically reaction will move backward to attain the equilibrium position. In a similar manner, if we remove the if we decrease the concentration of ammonia, automatically more reactant will react together and form more ammonia, and position of reaction will shift towards right. This is the effect of concentration. Either the reaction is taking place in which state, in solid, in liquid, or in gaseous state, the effect of concentration is same. Secondly, we can judge the effect of temperature. For example, this ammonia formation is exothermic. This is exothermic process. This is exothermic process, means heat energy is released during this process. It means if the reactions are exothermic, then low temperature, by decreasing the temperature, reaction will move towards right. Reaction will move towards right. And on increasing temperature, the reaction will move in the backward direction. But sometimes it is asked that this reaction is exothermic and low temperature favor, then why we are maintaining 450 degrees centigrade for this process? The answer is, no doubt, low temperature favor the formation of products more and more, but at a very low temperature, these bonds of nitrogen triple bond and hydrogen single bond, these are very strong bonds. They will never break easily. That's why we use high temperature to break these reactants bonds, and also we take help from the catalyst to break all the bonds of reactants so that these reactions can be converted into the products. No doubt, due to the exothermic nature, low temperature favor, but as the bonds of a reactant molecule will never break at a low temperature, so the feasibility or economical viability of the process decreases. No doubt, the efficiency increases. No doubt, efficiency increases, but the bonds are very strong, which will not be broken down at a low temperature. That's why we compromise the situation and increase the temperature to 450 degrees centigrade, which is the optimum temperature for this process. It means that exothermic, no doubt, exothermic reactions are moved in a forward direction by decreasing the temperature of the surrounding, and the exothermic reactions will move backward if we increase the temperature of the surrounding. This is the effect of temperature on equilibrium. Next is the effect of pressure. Effect of the pressure. Consider that if we assume number of volumes. Now, this equation is indicating that 2 volumes of ammonia is formed by reacting 1 volume of nitrogen with 3 volume of hydrogen. It means that total volume of reactant are 4 volumes, while the volume form of the products are 2 volumes. Now, as the volume is decreasing in product side, that's why according to the Boyle's law, if we will apply high pressure, definitely reactants will change into the products more easily. This is the effect of volume. But in case of gaseous state, whenever we will increase pressure, on increasing pressure, gas molecules will come closer to each other. Automatically, their number of collisions per unit time will increases. So the chances of formation of activated complex increases, which increase the rate of reaction consequently. But this will also apply to the products. Means products molecule will also collide and their chances of decomposition will also increases. It means that increase in pressure increases the rate of reaction in both directions. But if there is difference in volumes on reactant and product sides, then the effect of pressure will be significantly judged, and on increasing the pressure, reaction will move in that direction where the volume is decreasing. Next is the effect of catalyst. Effect of catalyst. For example, here in case of Haber process, we use catalyst as iron and iron trioxide. Now, the catalyst, the definition of catalyst is the substance which increase the rate of reaction both in forward and backward reaction. The catalyst, same catalyst is catalyst for the forward reaction, and the same catalyst is catalyst for the backward reaction. That's why it means that the catalyst will only increases the rate of reaction but will never change the quantity of the products or reactants. That's why the establishment of equilibrium will become much more easily and earlier in the presence of catalyst, but the catalyst will never change the quantities of the substances. In this manner, according to Le Chatelier's principle, we can easily judge by changing any of the factor on equilibrium position in which direction the position will be shifted. I thank you all.